All right, so today we're looking at transition matrices. So transition matrices are used in predicting what will happen in future basis. So things like companies will get a transition matrix worked out because they want to predict on how things will happen in the future. So we'll see a little bit later in a minute, like this one here is a car rental company, and they want to see how their cars are situated between all their branches and things like that. So used to predict things. So when we go from, let's say, it'll say that we go from one state to another. So we'll be talking about stuff like that. So when I said before, like say with the car thing, we might be saying, so in the month of March, there's so many cars at each branch, and then in the month of April, there's so many. So the state is month to month. So the state could be week to week, or day to day. They'll tell you what it is when they set up this transition matrix. So you might just want to take a note. A transition matrix is also a square matrix. We haven't written that there. So same amount of rows and columns. Okay, and the big importance thing is that each column adds up to 1. So you're going to see it's like a proportion, or we can talk about it as a decimal. So in today's lesson, we're going to look at setting them up. So here, if you just go through this example, so this was like a car rental place, as I said, and they had the 2 branches, Bendigo and Colac. And if you hired, you can see, if you hired a car at Bendigo, you'll see that it has this arrow going around that way, and it has an 80% on it. So what it means is that 80% of the cars borrowed or leased out, rented from Bendigo, 80% of them returned to Bendigo. So, but there was a couple when people rented it, there was 20% of those people who rented in Bendigo returned it in Colac. So you can see there's the percentages there. And then you've got, obviously they start talking about Colac as well, and 90% of those who rent in Colac return it in Colac, but then there was also 10% that returned it to the Bendigo branch. So this is a diagram, a transition diagram, so you might just want to write that down, that's a transition diagram. You could get asked to produce them from the matrix, but we've been given this one here and they've created a matrix. So as I said, it's going to be a square matrix. So how they got this, you have a look. If you look at what you're dealing with, so all the stops, so I've got Bendigo and I've got, we normally do it the other way now. So we've got Bendigo and we've got Colac, and then Bendigo and Colac. All right, so this B to B area will be all the ones returning. So you can see it's 80%. Now we don't, in transition matrices, put a percentage, we put the decimal. So 80% as a decimal is 0.8. Okay, but we saw those that took it from this and returned it to here. You can see from Bendigo to Colac, there was 20%. So I'll change that to a decimal there, 0.2. And then if I look at the blue, the Colac to Colac, that was 90%. So I'll write 0.9. That's where they get that. And those, if you've gone from Colac, returned it to Bendigo, that was 10%. So there's how they found that. So you've got to be really careful when you're setting them up. It's much easier to do the ones that go from itself to itself. Be really careful. A lot of errors come from when you're doing the other little ones. So we do that. Now, if you notice here, if you added these up, the columns, you can see that it equals 1. And the same here. equals 1. So that's a fact that will always has to be. So in a transition matrix, you always have to have the columns equaling 1. It's not a transition matrix if it doesn't. So that's a thing. So over here in this exam question, we can practice again. So what we're going to do is the families in a country town were asked about their annual holidays, and they had to choose whether they were staying at home. So we'll go home here, traveling, or they were camping. So you can see there. All right, so here, if I was to set up the transition matrix for this, we're going to have a 3 by 3 because we've got different scenarios. So we'll call it home. I'm going to follow what they did. So they did HTC. So if it goes HTC that way, down this way, it has to go HTC. And this we might say, now the state here, just so you know, it's every year. So this one, when we would be talking about what happens in the next state, so state to state for this scenario is actually year to year. Yeah. So before, this one might have been, oh, you can't see, I remember the example, it was month to month, I'm pretty sure. So this one's year to year. All right, so we've got a 3 scenarios, so we're going to have a 3 by 3. And as I said, it's often easier to do the ones that go back to themselves. So I'm looking for H to H, and that's 30%. So I've got to make it as a decimal, which is 3.3. And I might do the town to town, what was that one? Traveling to traveling. So traveling to traveling is 50%. So I'll put 50% there. And the last one, camping to camping. And I'm going to put that would be here to here. So that one's 0.6%. Okay, so those ones, that's the one I'm saying, are often easier to do. So if I have a look and I finish this one, if I go from home this year to next year, travel. So what I'm saying is this is this year, this is next year. Okay, so if I'm going from home this year, but next year I'll travel, here's 0.45. Okay, now because I know these columns have to add up to 1, here these two are already at 7.75. So really my last one should be 0.25. So let me go check if I'm on the right path, and I'm going to look for from home to camping and see if I get it. So I'm at home and I want to find the arrow that goes to camping, and you can see I got 25, which is what I said it should be. So that's a way I can check that I'm doing it correct. So I'm going to fill in the rest. So from traveling this year, I want to who goes back to staying to home. So traveling to home, I'm following this arrow here, and that was 30%. So there you go. Adding those two would get to 0.8. So this one must be 0.2, and I can see that on the transition diagram. And then, sorry, I've made this one a bit big. The last column, so I'm looking at camping, starting at camping, going to home is 40, 0.4. Now, if this is 0.4 and 0.6, that's already 1, so this would have to be 0. So there's no people who camp this year and go to, traveling next year. So that's there. So if you have a look, they all added up to 1. And then this was a multi-choice, so just to show you, we're looking for that answer, which to me looks like B there. Question 6. So the transition matrix V shown below, this month to next month. So just to show you, that is where the state to state, when they talk about you going to they're predicting or looking at state to state. This one is an example where it's going month to month. Okay, So the transition diagram below has been constructed from this transition V, and the labeling in the transition diagram is not complete. So the proportion for one of the transitions is labeled X. So this one down here is labeled X, and the value of X is. So what you're trying to work out is which one this is. So if you have a look, let's have a look. There's one that is saying, we have a station where it goes 0.4 out. So let's look down these columns here. I'm looking for one that has a 0.4 out. And can you see I found it there? So I'm going to say when you go from whatever M is to F, it's 0.4. So I know now that this is M and this must be F. So I've done that. Now I'm looking for, I'm just going to rub that out, sorry. Now I'm looking for, I'm going to have a look and see that something going from M out is 0.1. So if I look at what goes from M to 0.1 is T. So I've worked out this is T. So MFT. So this one, the last one left, must be, this must be L down here. So I want the one that goes from L back to L. So I'll go up to this transition matrix. I'm looking for L to L, which is this top one. So it's 0.6. So I've found that answer there. Okay, question 4. Stella completed a multi-choice test that had 10 questions. Each question has 5 possible answers of A, B, C, D, and E. For question 1, Stella chose E. Okay. So what we're talking about here, when they're talking about you're going from a state to state, for this one, it's just question to question. So that's how they've set this up. So Stella chose each of the 9 remaining answers in order following. So she followed this transition matrix. And it said, what did Stella answer for number 6? So what I'm going to do is I'm going to write out what she put for her answers. And we know she put E for this first one because that's what they said, number 1, E. So what I'm on, this question, she chose E. So if you look down, where's the 1 on the C? So that means the next question, she chose C. So I'm putting C there. So what you've got to pretend now, you are now at this question. So I'm at this question and I want to know what I got for the next. So I look down and there's a 1 on the A. So now I know that I'm writing A for the next question. And now I'm on A for this question and I go down and I have a look and I get D for question 4. Sorry. D. So now I'm on D. I'm going down till I find the 1, which gives me a B. So I'll put B. And just finally I'm on, sorry, just find another colour. I'm on B and I go down and I find that I'm on E. I choose E for the next. So what answer did Stella choose for number 6? I'm going to say E for there. That style question I have seen a couple of times. So very good to practice that. That comes up in the exams. Kids don't seem to understand it. So there we go. Question 6. The water park is open from 9 a.m. to 5 p.m. There are 3 activities: the pool, the slide, and the water jets at the park. Children have found to change their activity at the water park using this transition matrix. So this is from the state is activity to activity. The group of children has come to the water park for the whole day. The percentage of these children who are expected to be at the slide at closing time is closest to. Actually, I don't know why I put this question. You need this for later on when we do state matrix. I'll take this one out and pop it in that one. We'll just leave that one there.